EMFs, electromagnetic fields, a pernicious health risk. But how do they damage your health? Hi, this is Dr. Mercola helping you take control of your health. And today we are beyond honored and privileged to have someone to talk to and help educate us on this topic. And I believe there's very few people I've interviewed. I've interviewed a lot of people, but very few who I believe truly deserve a Nobel Prize for his pioneering research in this area to help us understand and identify the mechanism of how electromagnetic fields damage our cell. He's uniquely gifted to do this because he has training in physics and biochemistry, and I think one of them is from Caltech and the other is from Johns Hopkins, so two very prestigious universities, and then he's also a professor emeritus at Washington State University. And the man is Dr. Martin Pall, P-A-L-L, and you're in for an engaging, amazing conversation. So welcome and thank you for joining us today, Dr. Pall.
Thank you. It's a pleasure.
So before we start engaging this, I just want people to understand your background and why, as I mentioned, you're so uniquely gifted in this area, because most researchers don't have your skill set and training to understand the molecular biology of what goes on, how EMFs can cause this damage.
Okay, well, I got my bachelor's in physics and I got my PhD in biochemistry and genetics. And what I've been doing for the last 18 years or so is working on basically the medical literature, including basic science medical literature, putting things together that have been done by other people. There's a huge amount of information out there that, you know, that nobody's got time to read, nobody's got time to integrate and digest and make connections. So that's what I've been doing predominantly for the last 18 years. I was interested in EMFs before I could understand how they work. But and so when I stumbled onto basically two papers that told me, well, this looks like the way they work, and then I dug out more and more papers, initially 23 and then 24 and now 26. And actually there are a number of others I haven't published on. And they all show that EMFs work by activating what are called voltage-gated calcium channels. These are channels in the outer membrane of the cell, the plasma membrane that surrounds all of our cells. And when they're activated, they open up and they allow calcium to flow into the cell. It's the excess calcium in the cell which is responsible for most, if not all, of biology.
Yeah, and let's stop there in your journey, because that was the original. I mean, there's hundreds of studies that show that when you expose cells to EMFs, there's increased intracellular calcium.
That's right.
Yeah, and that's indisputable. That's just fact.
Yeah, and you also get increases in calcium signaling, which is very important.
So then you found these 24 studies and put the whole mechanism together. So I'm sorry I interrupted you. Why don't you continue?
Well, and so, the importance of this is that, the industry has been claiming for at least 25 years that, that ionizing radiation is dangerous, but this non-ionizing radiation can't do anything, and you don't have to worry about it. All it can do is heat things. And it's been very clear, going back all the way to 1971 and even before that this wasn't true. But we didn't know what the mechanism was, and now we do. And I think it's very important, basically, because the industry's been been trying to hoodwink everybody for decades, and and now we know how it works. And one of the other things that's very important about this is that there's a wide variety of different health impacts that have been reported, and now we can explain how all of them work. So, or at least all of them may work. And so they're plausible mechanisms leading off from this.
Well, let's go into, we really haven't discussed the mechanism that you put together, but why don't you bring us through the story of how you developed. You found these studies on calcium channel blockers, a whole variety of different ones, 24,
right.
And from there you developed the mechanism.
That's right. And so what the study showed was that you could block or greatly lower the effects by using calcium channel blockers, which are drugs which are highly specific for these channels, these voltage-gated calcium channels. And so that was the key observation. And as you said, and I said already, there are other observations that provide strong support for this as well.
Yes. So, well, maybe you can go some of the more details, because you had mentioned the heating effect, or what's commonly referred to in the literature as the thermal effect. The
Right.
industry only believes it's a thermal. Your
Right.
research shows clearly it's a non-thermal. But let's go into the mechanism of what happens. What do these calcium channels do? They open up, they allow calcium ions to go into the cell, which are really low concentration normally. But when they hit the EMFs, they open up and they put 1 million ions a second per channel into the cell and cause this molecular biological trauma that you figured out. So why don't you go into that?
Well, okay. So let me just say one other thing before we go. Okay. One of the other things about this is that these voltage-gated calcium channels, and I abbreviate them VGCCs, have in their structure something called the voltage sensor. This is a structure which detects electrical changes across the plasma membrane and opens the channel. So the obvious thing is that the EMFs are working through the voltage sensor to activate the channel. And what is true, and this comes out of the physics, is that because of the structure of the voltage sensor and its location in the plasma membrane, one can predict from basic physics it's extraordinarily sensitive to the electrical forces from these EMFs. And the forces are approximately 7.2 million times stronger on the voltage sensor than they are on singly charged electrical groups that are in the watery parts of the cell, the aqueous parts of the cell, which is where most of them are. So there are extraordinary forces on this thing, and that's how these very weak EMFs, which again industry claims can't do anything, are working. They're working by activating this, so that's critical.
Yeah, I couldn't agree more, and I think that's one of your major findings. And really, I just want to restate that in a way that some people may better appreciate. That the consequence of that assessment, which you put together, means that the safety standards that are in existence today are off by a factor of over 7 million. They're 7 million times off.
Yeah. This is an approximation. This is not a precise.
I know. It might be 6.3, it might be 8, who knows? Or it might be 4 million, who knows?
It might be
but
12
in that
million,
range.
it might even be 2 million, but the point is it's off by a hell of a lot.
Yeah, by many orders of magnitude.
Right, exactly.
Yeah, at least 7.
Yeah, okay. So then the question is, as you raised, so what happens next? How does this lead to what we call effects? And so there are a number of things that we know when you have excess calcium in the cell happen. And so one of the things is that you get excess calcium signaling. And one of the things that's critical in that is you get increases in nitric oxide. Okay? Now, nitric oxide can work through its signal. There's a nitric oxide signaling pathway. And that is the mechanism by which you get therapeutic effects. So there are genuine therapeutic effects that you get from these fields when they're at an appropriate level and when they're focused on a particular part of the body which needs some help. You can get therapeutic effects. However, what we're concerned about most, obviously, are the pathophysiological effects, the damaging effects that cause various kinds of diseases. And so how do they work? They work, I believe, predominantly by 2 different pathways. One is that nitric oxide can react with superoxide, and superoxide levels also go up in response to increased calcium in the cell, intracellular calcium. And they form peroxynitrite, which is a potent oxidant. It's not a free radical, but it breaks down to form reactive free radicals.
It's a reactive nitrogen species instead of reactive oxygen.
Well, it's both.
Yeah, okay.
You get both, and you know, because you get hydroxyl radical, you get carbonate radical, and you get.
Yeah, that's a question I had for you. Is it more, what causes most of the damage? Is it the peroxynitrate or is it the hydroxyl free radical?
I think, well, it's not just hydroxyl, because the other free radicals are important as well. I think both of them do it, but I think most of the damage is caused by the free radicals rather than peroxynitrate. But some of it is caused directly by peroxynitrate.
Okay.
And so you get a lot of, and of course, as you know, probably better than almost anybody else, you know, oxidative stress and nitrosative stress are involved in almost every chronic disease you can name.
Well, let me stop you there.
Yeah.
Because the devil's in the details, and you know, this is part of the solution. I think it's not oxidative stress. The adjective that needs to be inserted is excessive oxidative stress, because there's a certain baseline free radical that's biologically useful and necessary. Like nitric oxide is a free radical; you need it, but it's excessive nitric oxide, especially from stimulating the EMF, that causes the damage. The excessive oxidative stress.
Yeah, I think so. And what's interesting, actually, and this I've published on, but not in any place you can find it easily, is that those two pathways we've just talked about, the nitric oxide signaling pathway and the peroxynitrite pathway, each of them inhibits the other.
Oh, I didn't know that.
Yeah, and so, you know, if one of them gets turned on, it tends to suppress the other one. And so they're sort of, depending on the condition, one of them may be dominant or the other may be dominant. And so I think this is an important thing for understanding this.
That is so interesting, because I didn't develop this technique. It was developed by a friend of mine, Dr. Zach Bush, but it's a series of short exercises, take about 3 minutes, that essentially is a high intensity exercise, but the sole purpose of that exercise is to increase nitric oxide production. And I had no idea until you just mentioned it that will actually lower damage from EMF stress.
Yeah, it will do that. And so, you know, so one of the things I think that's interesting here is that the EMFs can, to some extent, and I don't want to overstate this, produce opposite effects depending on the conditions that you're using, the tissues that are being exposed, and so forth. So because these two pathways basically act against each other. And so that's, I think, you know, and so, you know, when the industry looks at studies and they say, oh, well, this produces hypertension and then it produces hypotension, and so, oh, they must all be wrong and there's no effect. Well, this, of course, is sheer nonsense, because the conditions that are used are different. So you can get hypertension and you can get hypotension from EMF exposures. So, you know, so you have this kind of nonsense stuff that comes from the industry all the time that simply, you know, when you look at the actual mechanisms, there's no basis for these arguments.
Yeah, well, let's talk about that industry. I don't know if you've studied it, but many other people have written books about it. But many people watching this may not be aware that this industry, the telecommunications industry, is well-funded, and perhaps maybe even more well-funded than the pharmaceutical industry, and do a very, very effective job of lobbying federal legislators and connecting with the media to give them disinformation that only supports their position. And in the same part is that they actively discredit, they've got these campaigns, any researcher that comes up with opposing views is discredited and they're defunded. We see it with Monsanto does it classically, and in the drug companies.
Yeah.
So do you have any experience with that, or can you elaborate on that at all, or is that what we go to other experts for that?
Well, no, I know a lot about it. I know how they've attacked various people, and I know that, you know, in the U.S., you know, we take great pride in our science, and we have more Nobel laureates than any other country, et cetera, et cetera. But basically the funding for the EMF research was cut off starting in 1986. And what happened was that the EPA had some internal research that was going on there.
Mm-hmm.
Funding for that was cut off in 1986. The U.S. Office of Naval Research had been funding a fair amount of research in this area.
That was in the 70s, 1971.
Yeah. Back in, well, they were funding stuff, and after that too. And they stopped funding new grants in 1986. So there were grants that had been funded already in 1986, and they went to the end of the grant period, but no new grants were funded. And then the NIH a few years later followed the same pathway. And so, so what's true is that now in the U.S., it's absolutely shocking to say that, what I'm going to say is that there are two countries in the world that are doing a lot of research in this, well beyond their normal scope. And they're doing vastly more than the U.S. is doing. And they're Turkey and Iran. It's surprising. I mean, there are other countries that are doing research in this. It's not just them, but it's interesting that we have two countries that we don't think of as being scientific powerhouses in any sense. But in fact, they're doing quite a bit of good research in both of those countries. And on EMFs. And we need to give them credit for it. So so the U.S. is way down the list because basically
it's been suppressed. And the average person doesn't know that. It's hard to do science when you aren't funded. Really hard.
Yeah.
And the industry knows this. They know this. They understand how research gets published. So neither of us, or I think any credible health clinician, is questioning the value of objectively done science, but it can't be done if you're not funded. Well, it can be, but it's just more difficult.
Well, it's very difficult to do, run a research lab with no money. I mean, you can't do it.
Right.
I mean, what I've been doing on my own. I've been contributing my time to it and my efforts and to at least a small extent some money to it, but it doesn't cost that much.
Yeah.
So I can do it.
Yeah. Well, you're doing the literature research. So, and the world owes you a debt of gratitude that they have no understanding of what you're doing, and really establishing the groundwork, the foundational basis for fighting this craziness that has been allowed to persist for the last 50 years, and is only going to get worse. Only going to get worse. Mm-hmm. Unless we take action. So, and you've got the basis of how we can take action. That's why I'm so excited for your work.
So let me just go back to the industry thing.
Sure.
For a minute here. So we have the fact that the money was cut off, and one strongly suspects the industry had a role in that. The industry with the 1996 Telecommunications Act gave the regulation to the FCC, which has done nothing in terms of protecting the public, and we have, in addition, prevented the public from protecting their health with regard to their exposures from the cell phone towers. We could not sue to prevent a cell phone tower from being put, near our workplace
and I believe the laws have been changed or pretty much set up like they did with vaccines. It's physically impossible to sue a vaccine manufacturer for damage. And I think they've set something similar with the telecommunications industry where you can't sue them.
That's right. Yeah.
They have immunity to litigation.
Yeah. So basically what the Congress did was to say our health makes no difference.
Yeah, right. And it's not getting better. I mean, the new head of the FCC is the lobbyist for the telecommunications industry. How crazy does that get? That is putting the fox guarding the hen house I mean, it's making them the head farmer.
So the corruption in this thing has gone, it's been bipartisan corruption. It's gone through, Reagan last term, Bush 1, 2 terms of Clinton, 2 terms of Bush 2, 2 terms of Obama, and it's continuing even worse under our administration. So we're in extremely deep trouble, and I think, but we really haven't talked yet about why we're in deep trouble.
Okay, well, let's go into there, because this is the reasons, because I think where you're going next is to where's the highest density of the voltage gated calcium channels, and what diseases are going to be a consequence of that exposure.
Right. Yeah. Okay. So the VGCCs have. Okay. Let me before I do that, I just want to say that a lot of the pathophysiology also has to do with excessive calcium signaling.
Okay.
And so it's not just the peroxynitrite pathway. That's very important, but it's also true that there's a lot of excessive calcium signaling effects, and and so calcium signaling is very important, and so when you got way too much of it, you have lots of problems, and that's another part of this story that's important to keep in mind. Okay, so let's go on. Where are these VGCCs? Where are they located? They're the highest density is in the nervous system, and there's studies going back to the 1950s and 1960s. Rodent studies that showed that the nervous system was the #1 organ in terms of sensitivity to these EMFs, and so there were studies done that showed that there were massive changes in the structure of the neurons, including cell death and including dysfunction of the synapses and many other things. So the brain is very sensitive. The heart is also sensitive, and I think that the pacemaker cells of the heart are particularly sensitive because they have the highest.
It's good to say that, but I just want people to know that the consequence of that sensitivity means cardiac arrhythmias, atrial fibrillation, atrial flutter, PACs, PVCs. If you have these things, EMF is a massive contributing factor that you've got to pay attention to it.
Yes.
We'll discuss that later, but so cardiac arrhythmias.
Yeah, they're cardiac. Yes. Well, also tachycardia and bradycardia, so fast heartbeat and slow heartbeat.
Okay, good. So those are others.
And we also get heart palpitations.
Which is a PAC or a PVC.
How each of those are generated, but I think that...
well, it's typically a premature atrial or ventricular contraction. That's what they call them, PACs or PVCs. So palpitations.
Yeah, okay. And yeah, okay. So, and as I'm sure you know, arrhythmias are often associated with sudden cardiac death. We have a epidemic of young, apparently healthy athletes dying in the middle of an athletic competition, something that was extraordinarily rare in previous decades. Now it's, last 2 decades, it's been happening more and more often. I think it's due to EMFs. I can't tell you for certain that that's true, but it certainly, as far as I can figure out, the only reasonable hypothesis explains it. So there are those things. Okay, now there are also effects on reproduction, and the VGCCs have very important mechanisms in the reproductive, and basically in fertility.
Is it more the testes or the ovaries?
The testes have been more studied.
Okay.
I think it's both.
Okay.
But there's much more data on the testis, and there is evidence for both causing male infertility and female infertility. But the male infertility is been much more studied. Okay. It's much easier to study. So I think it's both, but maybe I can tell you about a classic experiment that was done on reproduction. That was published 19 years ago by Magras and Xenos in Greece. They studied, they took young pairs of mice, one male, one female, put them in a little cage on the ground outside in an antenna park. So we have a bunch of broadcasting antennas, and the levels at the ground were well within our current safety guidelines. So if the safety guidelines have any merit, there shouldn't be anything happening. And they put them in two different locations, one with a bit higher level exposure, one with a lower level exposure. What they found was that at the higher level exposure, each pair produced 1 litter that was approximately normal size, maybe a little bit down, and then a second litter that was clearly down in numbers, and then complete infertility, not a single mouse born. Now it only takes 30 days, the gestation period in mice is about 30 days, so it takes about 30 days to go through these things. So it's a quick experiment. At the lower level exposure, it was basically the same story, except it took twice as long. Okay, so they produced, in fact, 4 litters with decreasing numbers and then complete infertility. So, you know, and we have now in humans, in many countries around the world, decreased male sperm count.
Yeah, down by 50%, over 50% in most countries.
And over 50% in Western countries, and about half that amount in other countries around the world. And you know, and the author, the senior author of that paper is saying, well, if this keeps going, we're going to become extinct. And just from the drop in male sperm count.
Yeah.
So we know that that occurs in humans, in, you know, people who carry their cell phones in their front pockets, people, you know, men who use their laptops with the Wi-Fi on, sitting on their lap. We know that occurs. Of course, industry denies everything I have to say.
Sure.
Put that in. But you know, and so you know, and we know we've got great increasing. Oh, by the way, it also occurs and this has been studied in animals in Wi-Fi fields.
No question. But I want to go back. You mentioned the extinction of the species, and I think you're spot on, and this is what we are contending with. You have the decrease in fertility, but you also have, you mentioned the nervous system, the increased density there, but you didn't mention the consequences of that. And there's 3 consequences, the A's, which should be anxiety, because their voltage-gated calcium channels are responsible for the neuroendocrine hormone release of neurotransmitters, anxiety, depression, autism, and Alzheimer's. So why don't you expand on that, because you gave a brilliant presentation at Autism One.
Thank you. Okay,
So,
you've been doing your homework. I'm impressed.
Yeah, so if we got autism on one end, the beginning end, Alzheimer's at the next, and you're not fertile, what's going to happen to humans? Are we not going to be, there's no 22nd century.
Yeah, and they're well, let me just go off on something else, because
Okay, sure.
the one thing that I've really published on in you know, substantial detail on that are the neuropsychiatric effects.
That's
And
right,
so, you know, I already said you get you know, massive sort of cumulative effects on the brain in animals exposed to these EMFs. You know, the VGCC mechanism predicts that you're going to get massive effects in the brain, because there's, you know, because there's some, you know, there's such high densities and they're so important in the brain. And we also have, interestingly, genetic polymorphism studies, which show that elevated VGCC activity for the most important one in the brain and produces various kinds of neuropsychiatric effects. So we know you can get neuropsychiatric effects from these from this mechanism, and and what I did was I reviewed a whole bunch of studies on various kinds of EMF exposures, each of them showing neuropsychiatric effects. And so what you find is that these effects have been repeated many times in these epidemiological studies. Are the same things that everybody's complaining about. I'm tired all the time. I can't sleep. I can't concentrate. I'm depressed. I have, I'm anxious all the time. All the things. My memory doesn't work well anymore. Sure. All the things everybody's complaining about. We know all those things are caused by EMF exposures. Mm-hmm. So there's no doubt about that, okay? And, because we know their effects on the brain. We know that the VGCC's excessive activity can produce various neuropsychiatric effects. And here we've got, all this epidemiological data that confirms this is happening in humans. Who live near cell phone towers, who are exposed to Wi-Fi, who were exposed to broadcasting radiation, who use their cell phones heavily, et cetera, et cetera. So, that's going on. And, so that's, very important. And I think
let
me should be any doubt about this.
Yeah, let me expand into this, because the other issue is cancer. And I think I just wrote a book, Fat for Fuel, which really discusses about the metabolic theory of cancer and focuses on the function of the mitochondria. And it seems to key in perfectly what you're teaching, because the EMF actually causes excessive oxidative stress, which can damage mitochondria. Now, you mentioned early on that these VGCCs are in the cellular membrane. I don't believe they're on the mitochondrial cell membrane, though, are they? Just the external cell membrane?
I'm not sure about that. I tried looking that up, and I'm not sure whether there is or is not.
But anyway, this excessive oxidative stress can damage mitochondria. We know that contributes to cancer. That's why women who put their cell phone in their bra get cancer in the upper inner quadrant, which is a very rare place to find cancer. It's almost always in the upper outer quadrant. And people who get brain cancer. So, in some ways, I think the publicizing and emphasizing the danger of EMFs to cancer is counterproductive, because most people don't know people with brain cancer dying from cell phones, and they know everyone who uses cell phones. But what they do see is people dropping like flies from lack of energy, from heart attacks, from cardiac arrhythmias, from autism, from Alzheimer's. This they see. So they have to understand it's not just the brain cancer, it's everything else. That's the key.
Yeah.
So do you
in my judgment, cancer is down around number 4 or number 5 on the list.
Yeah.
Of my concerns, and it's not that there's anything about cancer that's not important. I mean, it's very important, and we're just looking right now at the early stages because of long latencies.
Right. And let's address that. The latency is, there is virtually no one watching this. Less than 1% of you had a cell phone in 1995 or 1997. So we're talking about 2 decades. That's it. And then there was a progressive increase. Most people, it's probably this century that they had a cell phone. So it's not that long.
The studies on cancer have been blocked in a lot of ways by the industry, in particular by preventing researchers from getting information about how heavily the cell phones have been used. So basically, you can't get the information about how heavily individuals have been using their cell phones, even if they're willing, even if the individuals are willing to have the data released, you can't get that. From the industry, they won't give it to you. So basically, obviously it's the people who use most heavily that are at great risk, and there is some epidemiology that shows that. But it's been much harder to get because of the industry position. So, I think, but the other thing I want to say is that with regard to cancer, we know that EMFs cause DNA damage to our cells.
Single and double stranded breaks.
Single and double stranded.
By
Also,
the alkaline comet assay, right?
yes, and there's also a lot of data that's never been reviewed, but there's a lot of data that you get excessive level of oxidized bases, and particularly 8-hydroxydeoxyguanosine in DNA.
I got one question on the DNA breaks. What do you believe causes more DNA breaks? Ionizing radiation in the air, gamma rays at 40,000 feet, or conventional X-rays or CAT scans, or regular use of the cell phone? It seems like from your literature, you're thinking it's the microwave radiation is going to cause more DNA breaks.
Well, yes, I do think that's true, and so the question is, what's the evidence on this? And so there were 3 studies that were published by a group in Germany, headed by Professor Franz. I'm sorry, spacing out here.
All right, what are the studies? Yeah. So they're in German.
Yeah, Franz Adelkoffer, and he did 2 of these in collaboration with Hugo Rudinger in Austria. And the first study was done where they compared ionizing radiation, the equivalent of 1,600 chest X-rays. These were done in cell culture. They were done with, and they compared them with the DNA breaks that you got from what they described as 24 hours on a cell phone. Okay, and I'm going to tell you that it's actually not a cell phone here that was studied. And what they found was equivalent amounts of, or roughly equivalent amounts of DNA breaks from the 2.
So 2 days on a cell phone equals 1,600 X-rays, DNA damage in
24 hours. Yeah, okay, 1,600. Yeah, chest X-rays. Right.
In vitro assays.
That was what they found. Now, in fact, that underestimates the effects of cell phones. Okay. First, because they used a continuous wave EMF.
Oh, and it's not pulsed. Yeah.
And we know there's extensive evidence that the pulsed EMFs are much more damaging than the continuous wave EMFs. That's important for quite a number of reasons, including the fact that all wireless communication devices communicate via pulsations, and so they're much more dangerous because of that. And so then they published 2 other papers. One was they compared a pulsed EMF with a non-pulsed EMF and showed, yes, it was more active. And then they did a 3rd paper, which is the paper that industry loves to hate, which was the senior author was Schwartz. So it's Schwartz et al. Paper. And these are all published in English, by the way. And in that paper, showed that when you use pulsations that were designed to be similar to what the pulsations you get from a real cell phone, you got still much more damaging at much lower intensities. So, so cell phones are highly active, and so this raises a question: how can this possibly be? And I think the answer actually comes from the kind of diagram that I've published, which is how how EMFs produce free radicals. Okay.
Right. And we'll have a copy of that in our article so that people can see that.
Okay, great. So what you get then is that both ionizing radiation and the microwave frequency EMFs produce DNA damage through free radicals. Okay, so they're similar in that way. And the way in which you get the free radicals is through the peroxynitrite pathway. And it turns out that when you go from the EMS to the free radicals on that pathway, there are 3 steps that involves high levels of amplification. So one of them is, as you mentioned before, when you open up the channels, you get about a million calcium ions flowing in per second. The second is that you get increases in nitric oxide and superoxide, and so those, in effect, the calcium's acting catalytically, because once it's in the cell and as long as it's elevated, you keep getting more and more of those things. And then those two react with each other to form peroxynitrite, and the reaction rate's the product of the two. So you have 3 levels of amplification. Well, you have 3 levels of amplification, you can get a hell of a response to a very small.
Yeah, so it is interesting because it's true. The industry is saying that there's not enough energy in a microwave radiation to cause direct damage to the covalent bonds in DNA. There isn't. The energy in it. It's only biological amplification resulting in excessive oxidative stress that causes it. But interestingly, that ionizing radiation that causes the damage, I think in one of your papers you mentioned too, that ionizing radiation that has the energy to break the bonds, but actually more of the breaks are due to the secondary oxidative stress that breaks the DNA. It's not directly from the energy within the radiation.
Right, yeah. And then that, that was known, that was published by Arthur Compton back in he got the Nobel Prize for it in 1927. And the way in which ionizing radiation works, it basically hits molecules and atoms and knocks electrons out, and you get pairs of free radicals generated. And that's called Compton scattering. Yeah. And so there is amplification from ionizing radiation, but it's only at one level, namely that one that we just mentioned. Right. You get 3 levels of amplification with the microwave frequency EMFs, and so the amount of damage you get, based on those studies, is truly extraordinary. And of course, as I think Adderhofer and Rudinger have been severely attacked by the industry. Oh yeah. And, he has an interesting history. This is absolutely beautiful work. I mean, this is.
Yeah, I think it was his organization Veritas. He was hired by the tobacco industry initially, funded in Germany, and Deborah Davis did a nice job in explaining his whole process. Yeah. But I want to get back to what we can do, because now that we've hopefully you have appropriate concern about this issue now. So what they can do, and I want you to help us understand, prioritize our exposures. So that would be really good to understand, because let me name the exposures. Cell phone towers, which I think are relatively low down on the list unless you're right next door to one. Cell phone towers, your cell phone, which is a huge one, Wi-Fi routers, Bluetooth headsets or any Bluetooth objects, the Internet of Things, smart thermostats, baby monitors, and I think what may be the most important, smart meters, and then one of the most important ones, which hardly anyone looks at, is actually the microwave itself, which initially was developed as the radar range. Microwaves are radars, okay, that's the signals they use. Yeah. But I'm going to shoot a video right after this showing people that there's different units, there's different devices you can get to measure microwaves. And no, it's not a tri-field Gauss meter. That does not measure it. You have to get a specific device to measure from a few hundred gigahertz to a few hundred megahertz to the gigahertz range, and see what it is. But it's like when you turn on your microwave within 10 to 15 feet, it's 1,000 times higher radiation, 1,000 times, which is more than your cell phone. So I wonder if you can, from your perspective, you could prioritize those risk factors so that people know, because the first step in helping yourself and your family is to limit the exposure.
Yeah, I mean, okay, so let me just say, I've researched at least some of the evidence on, on cell phone towers, on cell phones. Cordless phones, by the way, are also problematic.
Oh, I forgot those. Yeah, we didn't have a comprehensive list, right?
And Wi-Fi and smart meters. There's very little data on smart meters, basically for the reasons I talked about before. There's no money, and so but what data we have looks bad, and certainly the anecdotal reports that one hears those are bad. But they're all bad. You know, all of those are bad. Microwave ovens, I'm not so sure about because I really haven't researched that.
Well, you know, you don't have to guess. You can buy these meters. They're not horribly expensive. They're only hundreds of dollars. They're not like thousands. And you can buy them and measure it yourself in your microwave oven in your home.
You know, and I use a Cornet meter pretty regularly. But, you know, but the problem basically is the following. We know that, you know, as I mentioned before, that the pulsed EMFs are in most cases much more active than the non-pulsed EMFs, or continuous wave EMFs. Mm-hmm. And but the other problem is
it microwave oven continuous or pulse? Is it continuous?
Well, it's pulsed, but it's pulsed basically because it runs off the 60 hertz current.
Oh, okay.
Okay, so you have a particular kind of pulsation, and so it's not just a question of how much you've got, but how dangerous is that kind of pulsation mm-hmm. versus other kinds of pulsation. So it's not an easy thing to compare. It's not an easy thing to say. I think in general, and this has been argued by a number of people, including Dimitris Panagopoulos in Greece, that in general, the more pulse things are, the more dangerous they are. But that's sort of and that's at least roughly right, but it may not be precisely right. And I think so we have a lot of problems, but in general, it's not that easy to make the kind of health assessment, without data. But the basic problem we have, the fundamental problem we have, is that not one of these devices, not even once, are tested biologically for safety mm-hmm. before they're put out to expose an unsuspecting public. They are never tested for safety. All the assurances of safety are based on this theory that they can only produce effects by heating. And we've known, if we're paying attention to the data, that was wrong 45 years ago.
And even with that flawed assessment, there's still warnings on every phone to hold it more than an inch away from your head.
That's right. Yeah, right. Yeah, that's right. Which people don't know about.
Right.
Because they're in very fine print. Yeah, it's bizarre, and as you mentioned before, my best estimate of the safety guidelines is they're off by a factor of something like 7.2 million.
Yeah.
We're in an absolutely insane situation. I mean, it's just crazy.
But it's important to know, what I've neglected to mention is that your understanding of this came in 2012. You published in 2013. It was a highly cited article and still is, won an award. So it's only been published for 4 years.
Yeah.
And you've had some effort. We're going to seek to publicize this and make this public aware, because once you know the mechanism, you can remediate. And I want to talk about that now, if I can, is that you put together the mechanism through the 24 studies that had calcium channel blockers. And I instantly thought of, I personally would never use a recommended drug. I mean, there's never, but virtually never recommend. Obviously, there's exceptions for every rule. But so what's the natural alternative from a calcium channel? It's magnesium. And virtually everyone's deficient in magnesium. So I'm wondering if you've reviewed if you have any thoughts on the molecular biology of high dose magnesium supplement. I'm talking like well above 500% higher than the recommendations, like maybe 2 grams of elemental magnesium a day, to serve as a blocker to stop, like the calcium channel blockers did in the studies, in the in vitro and the animal studies, to block the effects of the EMF or radically reduce them.
I don't know of any data on that. I've heard that there can be problems with very high levels of magnesium.
Yeah. Well, I want to talk to you afterwards. We're going to fund some research to look at that, because I think.
I mean, what I say is that the main problem with magnesium, I think, is the one that you mentioned before, and that is that almost all of us are magnesium deficient mm-hmm. because our diets are low in magnesium. and because the soils have been depleted in magnesium. And so I think that a lot of the effects, so it is clear that when we're deficient in magnesium, you get excessive activity of the VGCCs. So it's important to allay that deficiency. And the other problem—
that's documented. When you're magnesium deficient, you have increased VGCC activity.
Yeah, I mean, at least in animals, it's been shown.
Okay.
Yeah. And also cells in culture, you can show that. So yeah, and the other thing which is clear is that you also get excessive calcium influx through through the NMDA receptors, and so that's problematic as well. And so yeah, so it's certainly good and important to allay the magnesium deficiency, and you know, and I think, you know, I think we should all be doing that anyway.
All right. So the question is the research shows that deficiency in magnesium will contribute to enhanced VGCC activity, but it doesn't know that an increase in it would actually block that receptor. So we don't know that yet.
I don't think. Well, you know, the problem is that receptors are important for function.
Yeah.
So,
well,
you know,
but it's much better to block it with something natural than a drug, which is indiscriminate.
Well, I don't think we can block it. I mean, you
well,
know,
at least reduce it.
Yeah, and so yeah, there are other ways of I guess you know what I do, and I always tell people I'm a PhD, not an MD, and none of this should be viewed as medical advice. But I think one approach to dealing with these things is to raise the level of NRF2, NRF number 2,
yes,
which I published on.
Well, and that's a biological mimetic which upregulates hormetic. I'm not mimetic. Hormetic upregulates the superoxide dismutase, catalase, and all the other beneficial intracellular antioxidants.
Yeah, it does that, but it does many other things as well.
All right, tell us what else it does.
Well, it lowers inflammation. It improves mitochondrial function. It helps detoxify the body from both carbon-containing toxicants and toxic metals. And I guess that'll do for a start anyway.
Yeah, and so how do you activate NRF2? Well, the common way is sulforaphane from cruciferous vegetables like broccoli.
Yeah, but there are many other nutrients that raise NRF2. I published a paper on that.
Oh, you're going to have to give me that paper.
Okay, yeah, you can get it. You can pull it out of PubMed. Just
what's the title?
It just put in my my last name PALL and initials ML and NRF2, and it'll pop right up and you can download it.
Okay, good. Yes.
Yeah.
And
so,
I've got a novel targeted selective antioxidant that I think would be really useful that also stimulates NRF2, and I want to talk to you that off camera.
There are a lot of things that raise NRF2, and they include the long chain omega-3s in fish oil. They include a lot of phenolic antioxidants. Mm-hmm. They include sulforaphane you mentioned, the isothiocyanates from the cabbage fruit. They include I'm trying to remember which one. They include a lot of the sulfur compounds in garlic and onions. They include terpenoids. So a lot of the plant materials, mm-hmm. a lot of the things, in fact, a lot of things that occur in various kinds of herbs, including herbs that we eat, and also traditional herbal medicine. Yeah. So there are a lot of things that raise NRF2. They include the carotenoids, which I didn't mention.
Yeah, carotenoids would be good.
Yeah.
Interesting. I did not realize that carotenoids upregulated the NRF2 pathway. Did not know that.
Okay. Yeah. Anyway, you should read my paper.
I am definitely going to read it. Believe me, I will read it very soon.
A lot of good stuff in there. Yeah. Okay.
So you just provided us with the mechanism of how eating a healthy diet helps lower the damage from EMF exposure.
Well,
for the nerve 2
yeah,
pathway.
And you know, one of the things that I argued in that paper is the two most healthful diets known, the traditional Mediterranean diet, traditional Okinawan diet, are both high in nutrients that raise nerve 2.
Yeah.
So I think a lot of the health promotion of those diets goes through that pathway.
Excellent.
And by the way,
Yes.
to connect up with something else we talked about, the nitric oxide signaling pathway raises. And
Yeah,
that's
right.
how I think. That's how I think those two. That's one of the mechanisms important for those two pathways working against each other.
Yeah.
The nitric oxide signaling pathway regulates the oxynitrite
Did
pathway.
not know that either. Did not know that it affected nerve 2. So, but it's not just creating the nitric oxide, it's actually releasing it as a signaling molecule into circulation, which is what you do with the nitric oxide dump. Look up my video, my other video, maybe we'll put it in here, because you should do that if you're concerned about cell phone exposure, because you're going to lower your response to exposure, inevitable exposure. Yes, you should lower your exposure, get a meter, measure it, lower it as much as possible, but you also want to live a healthy lifestyle, and by doing that you'll actually improve your ability to withstand the damage from it.
Yeah, I mean, obviously avoidance is the key thing here.
Yeah.
And will always be the key thing here. But there are other things that are useful, and I think they should. Yeah.
Well, we've kind of reached the end of our limit that we're for a normal interview. So if you would like to emphasize some points or summarize it or make a recommendation for resources to go to, and then we'll conclude. And we'll probably have you on again because you're such a wealth of information.
Well, I think, yeah. The one thing to emphasize is that this whole nonsense that the industry has been putting forth is just that. It's just nonsense, and we are literally destroying our health in many different ways. And I think, we talked about the extinction issue, and I think there are actually 6 different ways in which it's probable that we will generate our own extinction rather quickly from these EMFs. But I think one of the things that's important here is that when you look at the effects of the EMFs on the brain, and when you look at the effects of EMFs on the reproductive system, they both develop slowly over time. Those are the things we're not aware of because they develop slowly. I mean, it's not like getting, hit in the head by something. It develops over periods of months and sometimes years.
Like smoking,
And so we're not aware of them, even though they have, they are cumulative and they develop quite severe effects. And so this is something where, where I think people are not aware of this because they develop slowly over time, despite the severity of the eventual effects. And that's something that, that I think all of us keep in mind.
Okay. Well, sage advice. Again, I cannot thank you enough, and I'm going to be a surrogate person, serve as a surrogate to express the sincere gratitude that we have for the pioneering work you have done in elaborating on the biological mechanism from EMF damage, which has such massive potential to really fight the misinformation of the telecommunications industry and really hopefully help us get back to biological safety standards, and not back to, but at least adopt them and to develop some remediation strategies that can actually limit or radically reduce the damage. So thank you very much.
Thank you for doing this.